You must have heard how flying objects spin or rotate with the earth. Why don't they move away and lag behind after being separated from the earth? If a helicopter flies for hours, it would still be right exactly where it was. Why doesn't the earth move beneath it? There are two answers given to this. First is, the entire atmosphere moves with the earth, meaning earth moves the atmosphere extrinsically with itself. The intrinsic motion is when an object does motion by itself, and extrinsic motion is when an object is stationary by itself, but something else moves it while carrying or lifting it. A plane and a passenger sitting in it, for example. The motion of the plane is by itself, while the passenger does not have any motion in his essence. The plane is carrying him and moving him. So the motion of the plane is intrinsic motion, while the motion of the passenger is extrinsic motion. Imam Ahmad Raza says if the earth revolves with the atmosphere and everything in it, three things are necessary. Firstly, the earth moves by itself because of the intrinsic motion and gives extrinsic motion to the atmosphere. Meaning, the earth must carry and move the atmosphere the way a plane carries and moves its passengers. Secondly, the atmosphere must give extrinsic motion to everything in it, like a phone in a passenger's hand, as the phone is moved by the passenger and the passenger is moved by the plane. Similarly, flying objects in the air, such as helicopter birds, must be carried and lifted by the air so that these objects are moved by the air and the air is moved by the earth. Thirdly, all these intrinsic and extrinsic motions must be in perfect harmony and synchronization so that they all look stationary and still at all the times, just how we witness the atmosphere and the flying things on the earth. Imam Ahmad Raza says, any body that is able to hold, lift, or support another object can move that object extrinsically, like how a waiter's hand can give motion to a tray and a set of glasses. The glasses and the tray are not in motion at all, but the waiter's hand is lifting and moving them. This is the extrinsic motion of the tray and the glasses. But water and air are very soft and sparse bodies. Their molecules are scattered, not tightly placed like solid. They are not even able to hold and support another solid object. How would they lift flying objects and move around with them like a one-piece body? Air and water are able to push and give motion to solid objects, like how a boat floats in water or leaves fly by wind. But this motion is never like a motion of passengers of a plane. There is quite a difference between dragging or pushing and moving around while holding it or lifting it. Dragged and pushed object will have compulsive motion. But in extrinsic motion, the object is always stationary and something else moves it while carrying it. Water and air molecules can definitely push or drag an object with them, but they can't hold a solid object with them and move around as if they are a single body. Therefore, the air and water bodies do not have the ability to move anything extrinsically with them. You might think that, okay, the atmosphere is not able to lift and carry around flying objects like helicopters, but the gravity of the earth definitely can. So the force that always brings everything towards the earth would keep on pulling the lagging helicopter to keep up with the earth. Helicopter will keep applying force to go away, and the gravity will continue to pull the helicopter behind the earth. Well, yes, gravity could keep pulling and bringing the lagging behind helicopter along with the earth, but gravity can never repel the leading helicopter. Things lagging behind can be pulled by the gravity, but things leading the earth can never be repelled by the gravity. The job of gravity is to bring towards the earth, not to move away from the earth. What should happen is, as soon as this helicopter moves away from the earth, it must be smashed on the ground. Because the earth moves 28 kilometers, meaning 28,000 meters in every second, and this poor helicopter can't even move 28 meters in 1 second. So realistically, as soon as a helicopter takes off, it either must go deep down the earth or be smashed on the ground. It is also proven by the Foucault's pendulum. In 1852, A French physicist called Léon Foucault noticed during an experiment that if a pendulum is left swinging on its own for a long time, it will change the swinging direction. He understood the reason behind this is the movement of the earth beneath the pendulum. So the pendulum does not follow the rotation of the earth and keeps swinging in its own direction. This phenomenon is widely accepted and shown globally in different museums and is considered a great proof of Earth's rotation. Now, whether this is true or not, but we at least came to know that science does believe that the pendulum will not follow Earth's rotation and will continue its own motion. So if a pendulum that is on the Earth and physically attached with the Earth will not follow Earth's motion, then how can a helicopter that is completely separate and detached from the Earth will follow Earth's motion? Why will it not continue its own motion after being separated from the Earth? Another answer is given with inertia. Inertia means when you try to move a motion-free body, it will resist and oppose. Similarly, when you try to stop a moving body, it will also resist to stop. This tendency of bodies to oppose is called inertia. That's why a person getting off the running train needs to run a few more steps, because his body opposes to stop suddenly. Similarly, this is the reason why in a running train, if a ball is tossed up in the air, it will land back in the same hand, even though the train kept running while the ball was up in the air. The ball never lags behind the train because of the inertia. Therefore, anything detached from the earth keeps running the same way even after being separated. Even though the earth kept running while it was up in the air, it never lags behind the earth because of the inertia. Our question here is, the inertia is always momentarily. It tops for a few seconds until that opposing force or energy is not depleted, meaning the inertia is not depleted. That's why the person getting off the running train needs to run a few steps so that the energy of the train in his body is depleted. Once that is done, he does not feel the train's force or energy on his body anymore. If the same ball is tossed up to such a height that will allow the train's energy to be depleted, it will definitely lag behind and the train will continue beneath it. If a drone or RC helicopter takes off from a moving train, it will clear this up right away. We found a video on YouTube someone doing this. It is clearly witnessed in it. Similarly, the helicopter taking off from a yacht continues in its own trajectory after taking off, and the yacht moves beneath it. Very much the same way, when a fighter jet drops bombs, they lag behind in just a couple of seconds. Also, when the skydivers dive, they fall behind as soon as they jump and the plane flies away from them. So if a drone or helicopter takes off from a moving train, it falls back. How does the helicopter taking off from the earth never fall back? So in short, inertia can never be a reason why a helicopter keeps up with moving earth for hours. Neither the atmosphere, meaning the air, has the ability to lift and carry around helicopters weighing thousands of pounds, nor the gravity can ever repel objects flying in front of the earth's way. So after all, why do objects flying away from the earth keep following the earth's motion for hours and hours? And if there is a reason, why the Foucault's pendulum does not follow the earth's motion due to that reason? And if due to some reason the pendulum is able to deflect from earth's motion, why is the helicopter not able to deflect due to the same reason? Though the helicopter is completely separate and detached from the earth, whereas the pendulum is physically attached to the earth.